Fine. So today we are going to discuss about LDP only, which is label distribution protocol, because in previous class we have already discussed about the basics of MPLS, that how does it really work and what is the advantage of enabling MPLS, where does it insert its own information, its own label, right? So we have already discussed all these things related to MPLS. So today we are going to start this LDP. As you know that LDP is like label distribution protocol. LDP is what? Label distribution protocol. So as I said that all routers will be responsible to generate your labels independently, right? I mean, labels will be having locally significant, right? So finally LDP will be responsible to distribute your label information among its all neighbors, right? Like for an example, this is R1, this is R2, this is R3. So in between R1 and R2, of course, you must have LDP peering. In between R2 and R3, you must have LDP peering, right? And then after, you will see that if there is any prefix onto R2, R2 will generate a label for that prefix and then will tell to its neighbor R1 as well as R3 that to, I mean, for this prefix I have generated this label. So this information will get exchanged with the help of LDP only. Like previously, routing protocols were used to exchange your routing information among routers, right? So here, to exchange label information between routers, LDP will be in use, right? LDP is label distribution protocol. As per its name, label distribution protocol, it means that it will be responsible to distribute label information between neighbors, between LDP neighbors, right? So that's the uses of this LDP. Now, as I discussed in previous class as well, like in LDP, it is mandatory that its router ID must be reachable. If router ID of LDP is not reachable, like router ID of LDP is quite different from other protocols such as OSPF, EIGRP and BGP, because in those routing protocols, I mean in those protocols, you could define anything as router ID, and it was not necessary that router ID should be advertised into the routing table or something like that, right? So here in LDP it is mandatory. In LDP, your LDP ID, which is also known as router ID, must be reachable. If that LDP router ID is not reachable, then LDP will never form neighborship. And I have also taught you, I think in previous class, that in between two devices, if you are having more than one connection, then also there will be only one LDP peering. I think I have already discussed it with you, right? So today we are going to implement all those things, right? I will show you that how LDP exactly works, how PHP works. I have also taught you PHP. Do you remember? Penultimate hop popping. So here let's say its IP address is 12.1.1. On R1, let's say there is a loopback address. On R2 as well. On to R3 as well. On to R4 also we are having one loopback. Fine guys, I have allocated IP addresses as per this diagram. I'm again back on R1 and see, I'm not running any routing protocol over here. I will simply show you that how to enable LDP, and I think in previous class also I told you that how to enable LDP over here. I mean how to enable MPLS, right? So I will be on S1 by 0 and here also MPLS IP. So MPLS would be enabled on this interface of this router. Show MPLS interfaces. So by default it will run LDP. It will not run TDP, right? Have you watched previous video? Did you watch previous video? I mean previous class video? Are you getting it? So LDP is there, and because LDP is running here onto this interface, and one more thing, that you cannot enable LDP onto loopback interface because it is not necessary to enable over there, right? Like MPLS IP. What? For MPLS IP, yes, you can also enable this command like MPLS IP, but finally you have to enable it under interface mode as well. Let me show you. Here I have enabled this under interface, right? Show MPLS interfaces. Then I will move on R2 as well, and here I'll say MPLS IP. Show MPLS interfaces. So finally you have to move under interface mode, and then you have to say MPLS IP, and then on to S1 by 1 also you can enable MPLS IP. Now you see show MPLS interfaces, so it will show you that on S1 by 0 as well as S1 by 1 MPLS is running, right? Now neighborship will not come up. Neighborship will not come up. Even you can see here, like I'm on R1 now, say show MPLS on R1, right? Show MPLS LDP discovery. What is it showing you? That our LDP ID is what? 1111, and you see by default LDP will pick its LDP ID in that manner in which OSPF picked its on router ID. Like first of all it will prefer to that which is configured statically, then highest loopback, and then finally highest physical active interface, right? So this time neighbors LDP ID is what? 2.2.2.2, which is by default, and there is no route available to reach that. That is why neighborship will never come up. I think in previous class also I discussed it with you, right? So in this manner you can see that there is no route available to reach it. That is why I said that in LDP ID must be reachable. So now what can we do? Router IGRP 1 noto, just copy and paste it on all other devices as well. Show IP IGRP neighbor, check it out. Show MPLS LDP neighbor. You see, this is my LDP neighbor, this one, and my neighbor's LDP ID is 2.2.2. My local ID is what? 1.1.1. Then TCP connection is there. This is our port number. I mean 646 is configured at our own end, and this is, it means it is initiated from 22222 because it is having random port number, whereas we are having what? Well-known port number. So this TCP connection was initialized from. Then you see source IP address is what? 12.1.2, because R2 is having this IP address. However, with using physical interfaces, it will not form TCP connection. TCP connection will be formed with using their LDP IDs, LDP ID addresses. But finally, it is receiving hello messages from where? 12.1.2. Then address is bound to pair LDP identifier, means on neighbor device, which is R2, out from these three addresses anyone could be LDP ID, but it picked 2.2.2. However, 12.1.2 is also configured on R2. 23.1.2 is also configured on R2, but due to highest loopback interface, it picked 2.2.2. In same manner, you can move on R2 and you can say show MPLS LDP neighbors. So it is also having the same thing. See, address is bound to peer LDP identifier. However, it picked 1.1.1, and then source address is what? 12.1.1, because we are receiving hello messages from 12.1.1.1, right? And hellos will be multicasted, as we have seen. I mean, we saw in previous class that hellos were multicasted with using 224.0.0.2 and with using UDP port number 646. And finally, TCP session was formed, right? In same manner, now I'm going on R3, and on R3 also I will enable LDP now. S1 by 0 MPLS LDP on, sorry.
Multiple protocol can use same multicast type.
Yes, of course.
Like 224.0.
So many.
So if we have to use the IGRP and OSP, then what is the use of MPLS?
If we have to use MPLS, EICRP or OSPF, okay. See, in future I will here. See, if I am using EICRP or OSPF, then every router, every hop has to open IP header and have to perform lookup. Now they will be able to switch their packets based on their labels only. That is the most advantageous thing about MPLS, right?
Yeah.
And if routers are switching your data based on their labels, it means somewhere in the network, if your some of the routers do not have your destination prefixes available in their routing table, then also they can switch your data. But right now all of them are having all those prefixes in their routing table. But in future, whenever I'll teach you BGP over MPLS, then I'll teach you that indirect neighborship of BGP. Do you remember indirect neighborship of BGP? In that case, edge routers were having prefixes but core routers were not having. But here you will see that I'll create same design, but this time you will see that there will not be any requirement of configuring GRE tunnel for BGP to establish communication. But here in MPLS, I mean, of course, without any GRE tunnel and all, MPLS can switch your data even it does not have destination prefixes available in its routing table. So these advantages will be there after implementing MPLS in your network. So very first advantage over here is what? That now routers will not require to open your IP header, so they can switch your data immediately. Just looking at their label number, right? Which is 4 bytes long information only, whereas IP header was 20 bytes long. So MPLS IP on R4, and now definitely it must form LDP peering. You see it has formed. And now in previous class I have taught you, we have proved it, that TCP session was formed with using LDP ID. Now very first thing, here we saw that on S1 by 0 I enable MPLS IP command, right? And after enabling this MPLS IP command under this interface mode, it enabled LDP over there, right? If you want to use TDP in place of LDP, then you can also use it. Like MPLS label protocol is what? This is the command which can be configured under interface mode, and now you will see that neighborship will not come up. In T-shoot they can do that. LDP will be running over there, but at one end they can configure TDP so that your LDP peering will not come up, and now your labels will not get exchanged. Now you can see, now show MPLS forwarding table. Is it having any outgoing label now? Is it having any outgoing label? No, it does not have any outgoing label, because you can see that outgoing label for each prefix, like to reach 444 is what? Untagged. It means it have not received any label from its neighbor, because there is no LDP peering in between R1 and R2. As you can see here, show MPLS LDP neighbors. Does it have any LDP neighbor now? Now you can see show MPLS LDP. Of course LDP do not have any, because LDP is not running over here at all. So now move again back under interface mode and configure MPLS label protocol as LDP itself. So once you will configure this label protocol as LDP, once again you will see that LDP peering will come up, and once this peering will come up, then let me do one thing here. Let me show you that, okay, binding will be exchanged in form of updates. So do one thing, say on R1 say clear clear MPLS LDP neighbor star. So now you will see that neighborship will be down and once again it will come up. You see, initialization message. Let me stop it now or it will get stopped, don't worry about that. See, first of all it has to form TCP session. So SYN has been generated by 2222 towards 1111, then SYN plus ACK and finally ACK. Then they will send initialization messages to each other as we saw, I mean we as I said previously, right? Hello. Then they will send initialization message. So first of all 2 has been sent initialization message towards 1, then 1 have given initialization message along with keep alive, and then finally 2 have given only acknowledgement back to, and then after you can see that now after it you can see here that they are sending label mapping to each other. So 2 is giving now mapping to 1 that I have generated these labels for these prefixes. You see LDP, this is also having here keep alive message, forget about it. Here you see label mapping message, label, you can open it, FEC element 1. See for 2222 what is it sending over here, generic label TLV. You see what is it sending, label number 3, which is implicit null because 222 is directly connected to R2. So whenever R2 will generate implicit null for directly connected prefixes and it will advertise that label information towards its neighbor. So from R2 we are getting this generic label 3 for prefix 22222, right? But if you open anything else like here, let me yes, open it. See, this is what, oh my god, 111. Yes, 333, right? For 333 it is telling us that your label is what, 18, and it is generated by R2 actually. You can move on R2 and on R2 you can see its local label, show MPLS forwarding table. So to reach 3333 what is its local label,
18.
So it is advertising its local label towards its peer in updates, you see, and it is going via TCP. You can check it. Hello. So only local label information will be given to its neighbors. So here we can see that now we are getting only local label information, as you can see for 444 as well. This is for 4444 and it is having label number 19. For prefix 44444 it is having label number 19, right? And now you can see that R2 generated 19 for 4444, right? That is why it is giving 19 to its neighbor R1. So I hope that you people have understood that how is it exchanging label information between, I mean how LDP is giving an update to its neighbor device, right, to its peer. So finally we are on R1 and you can see show MPLS forwarding table. Previously it was not having any information, as I mean it was not having anything in its outgoing label. It was showing me that outgoing label is untagged because there was no LDP peering, right? There was no LDP peering. Fine. So in this way I hope that you are okay now with it, that how LDP is advertising label binding information towards its neighbors. Fine. And then after, even you can also change your label distribution protocol globally as well, like MPLS label protocol, and you can use like LDP or TDP. So by default it is using LDP. See, default. Once you will configure TDP, once again your LDP peering will go down. Once again your LDP peering will go down. Show MPLS LDP neighbor. Oh, why is it not breaking up its neighborship? Oh, I this time I configured command under interface mode as well. So if you are changing anything globally and you have configured the same configuration under interface mode as well, then it will pick, I mean it will consider that command which is configured under interface mode. So S1 by 0 do one thing from here, just remove this protocol LDP command, and now MPLS label protocol, sorry, in place of LDP I have to use TDP. So you will see that neighborship will be down. Show MPLS LDP neighbor. Is there any LDP peering now?
No.
And you see that it will start to send now hello messages. See, TDP is also sending hello packets. You see this one. Oh my god. Wait. Where is that? Oh, yes, yes. 711 because for hellos it will also use UDP, and then after it will also use TCP. So you see, only hello, right? And it is broadcasted. So TDP is broadcasting it. However, port number will be 7. Fine. So this is for TDP. So here we are not going to run TDP at all. So again, say MPLS label protocol is what? Tell me. LDP. And once again you will see that your neighborship will come up. And once neighborship will come up, you will see that show MPLS forwarding table. So right now you are having your outgoing label, but if there is no LDP peering, then outgoing labels will always be untagged. Because at that moment you will not be receiving any label from your neighbor if you do not have LDP peering with your neighbor, right? So in this way you can do it, and then after if you wanna change, just try to understand. If you wanna change your LDP ID, then the command will be MPLS LDP router ID. And you see, under LDP router ID you cannot directly define your ID. You see, you can call only and only interfaces. You cannot say like one same as OSPF like 1.1.1. No, nothing like that. Say MPLS LDP router ID, and then you can call your loopback or physical interface. I mean, you can call only and only interfaces, because it gives you guarantee that okay, it is configured on this interface, right? So that it means that it will be advertising into routing protocol as well, because here in LDP it is mandatory that your LDP ID must be reachable. That is why there is no option to configure your ID directly like 1111 or 44444.
If we configure an interface and it takes the router ID from that interface, and after MPLS neighborship is established and the interface goes down, what happens then?
Neighborship will also go down.
And it will take a new ID and bring it up?
Of course. Like for an example, now I'm on R1, right? Say loopback 1 is what? Shut down. And on R1, see, it have came up now. You understand? It have came up.
Even if we use that
So MPLS LDP neighbor, you see.
Even if we hard code our router ID with that.
Then there will be problem. What
I noticed was it goes down and it takes up new ID from an interface.
Okay.
Is that
Wait.
a normal
I'm doing that. Now let's do one thing. Interface loopback 1. Say no shutdown. And once again say MPLS LDP router ID is what? Loopback 1. You understand? And you will see show MPLS LDP neighbor. Okay. Do one thing clear. MPLS LDP neighbors, and then start. Don't worry, LDP neighbors will come up once again. Still it is using Again it is taking 12.1.1. Have I shut down that loopback? No. Okay, there is one another command also exists, MPLS LDP router ID loopback 1 force. Actually, if you do not add force keyword, then it will not take place immediately. It says that whenever next time routers will get reloaded, then it will take place. But if you use force keyword, it is something like that you are saying in OSPF clear IP OSPF process. Do you remember that in OSPF, if we were changing its router ID, then it was not taking place until unless we were not clearing the process of OSPF, or it was necessary to reload your machine, your device. In same way, over here we are having this force keyword, right? So in this way you can change its router ID. And now what will I do? I'll move on loop back, and then I'll say shut down. Let's see. Yes, it have picked 12.1.1.1 as LDP ID, right? So interface loopback 1, say no shutdown. It will come up, router ID have changed, and once again LDP pairing will come up, and this time it will be using its loopback address as LDP ID. So MPLS LDP neighbor. You see, check it out. See, right, guys? So if they are saying in exam that okay, you have to use loopback as router ID, then do not forget to use this force keyword. Say MPLS LDP router ID loopback 1 and then force. After that force, after force you do not have any other keyword available. Fine, guys. So in this way you can modify the router ID of LDP. And then after it, let me show you something over here. Show MPLS. See, first of all I will show you that there is a prefix 111 which is directly connected to it. Let me show you. Show MPLS LDP bindings. So for 1111 it has generated what? Implicit null. Then it will advertise it towards R2. So R2 will be receiving it from R1. So MPLS forwarding table. You see, for 111 its outgoing label is what? Pop tag, because it received what? 3. It received implicit null. Hello. Implicit null means tag number 3. We saw over there. And then it has generated label number 16 for it. It means it will advertise it towards R3. So for R3, let me show you. Show MPLS forwarding table. For 111 outgoing is what? 16, and local is also 16. It means it will also advertise only 16 for towards its neighbor R4. Show MPLS forwarding table. Its outgoing is what? 16 and local is again 16 on to R4 as well, because it have local significance, so it doesn't matter. But remember, one router cannot generate same label for multiple prefixes. One router cannot generate same label for multiple prefixes. In same manner, it is having like 4444 as directly connected. So see, 444 is not available in its local LFIB. Does it? Does it exist? See, is there any 4444 on R4? No, because it is directly connected. So now you can see show MPLS LDP bindings. Here you can get label for 4444. So what is it? Implicit null. So now it will give it to R3 now, and you see, to reach 444 outgoing label is what? Pop tag, and local label is what? 18. It will advertise it now towards R2. So for R2 outgoing label for to reach 444 will be 18, and so, see, its local label is what? 19. So it means it will advertise it towards R1 with yes. Show MPLS forwarding table. So to reach 444 outgoing label is what? 19, and see. Understood? Hello. So what I taught you in previous class has proved over here, right? So now you can even try to check it out. See, on R1 set trace route 4.4.4. So it will show you that okay, it is using these labels. So of course, first of all, on R1 we were having its outgoing label to reach 444 was 19. Then on R2 we were having 18, and then R3 performed. Then R3 performed. Tell me. See. Right? Then have you got it? First of all, it have moved on R2 swapped 19. Then R3 swapped it. R3 swapped 18 with implicit null. Right? So see, R1 was having its outgoing label as 19. Then R2 was having its outgoing label as 18, and then R3 was having its outgoing label as, see, 18 will be replaced with the pop tag. So basically this popping has been done at the end of. That is why during when I said trace route, it does not have any label over here. Finally, I mean R4 did get this packet with label, because PHP is by default enabled. To prove it, actually, what can we do? I will capture this link. I'll capture this link, and also I'll capture the link in between R3 and R4. Sorry. Fine. Ping. This is the link in between R2 and R3. This is. I will open it. When packet is going from 1 to 4, see, label is what? It should be 18. Because R2 is sending this packet with the label number. Hey, I captured this link, this one. So when packet is going from R2 to R3, it is going with the label number 18. But whenever R3 will receive any packet coming with the label number 18, it will be sent it out from S1 by 1 and remove tag. Hello, what is the meaning by pop tag?
Remove.
That is why whenever you will open packet over here coming from 1 to 4, does it have any label over here? Hello. So popping is done by R3. Understood? Hello. Tell me, is there any problem? Then after it, we have also seen like trace route, fodder for, it is going via everyone, right? So now you can also configure this command like, okay, one more thing. TTL is there in label as well, right? TTL is available in label as well. So when a packet from non-MPLS domain gets entered into MPLS domain, then the TTL value of IP header will get copied back into MPLS label. And whenever label will be removed, last label will be removed, then the TTL value of that label will copied back into your IP header. Because in between, routers will not modify anything inside your IP header. Like this time, if you are sending any packet towards 4444 from R1, then R2 and R3 will never open the IP header of that. So finally, R4, how will it be possible for R4 to come to know that okay, it have came here after crossing that number, this number of hops, like 3 number of hops? So basically, with the help of label. I mean, whenever packet gets entered into the MPLS domain, then the TTL value of IP header will get copied back into label. And whenever your packet will go out from MPLS domain towards non-MPLS domain, then again TTL value of label will get copied back into IP header. Even we can check it out. Like, let me show you. I will open that IP pack. I mean that those ICMP packets. See, open it. if you open MPLS, what is that? Its TTL is what? 254. Very good. If you open IP header, its TTL is still what? 245. You know why? Because R1 have sent packets with TTL value 245. So when R2 received it, it modified TTL value in label only, not in IP header. Because R2 received packet with label. R2 received labeled packet. It didn't receive any unlabeled packet. Hello. Try to understand. R2 received this packet with label number 19. So it didn't modify the TTL value of IP header. It modified the TTL value of label itself. Then it have given it to R3. So when R3 is giving it back to R4, at that moment it was not having any MPLS label. So TTL will be modified of your IP header itself. You see what is this? 253. However, see, R3 was receiving IP header, was receiving TTL value as 255 in its IP header. Hello. Hey guys, what are you doing? See, modification was done in the TTL value of MPLS label only 254. But finally, when R3 received it, it came to know that okay, it has to perform popping. So it have copied the TTL value of label back into IP header. If you do not want to let your routers to do that, then you can also configure this command: no MPLS propagate MPLS IP propagate TTL. So it will not propagate your TTL values now. Configure it on all devices. Say no MPLS IP propagate TTL onto R3 as well. No MPLS IP propagate TTL onto R4 as well. No MPLS IP propagate TTL. Move on R1 and say trace route. What is it? It is directly showing you now your destination, because now you have you have hidden your network, because now TTL is not propagating in your MPLS label. That is why it will show you that it has directly reached your destination. So if you wanna hide your MPLS domain, then this command will be required to configure on all devices where MPLS is configured. So it is looking like that we are directly reaching. Yes.
Export security purpose.
Yes. That is why to reach google.com users, you are required to like across only 10 or 12 devices, not more than that, because everybody, all service providers have configured this command. So after getting enter into their network, it will not show you any router over there, right? It will show you only exit router only. And that is why sometimes if you do trace route your google.com, it does not show you label and all. Like, let me do that now. No label, right?
फिर फ्रेश रूट की लिमिट होती है 30 ऑप्शन
30
हम
option.
सिर्फ इंक्रीज कर सकते हैं.
Fine. So now in LDP itself, we have so many things to do, right? Still we have so many things to do, right? Like sometimes what happens, just try to understand that we are sending some packets towards 44444 with some higher priority, with some higher priority. Now higher priority will be given into your IP header with the help of toss value and quality of service, right? I mean, when we talk about the quality of service, it means we are talking about the toss value only, toss type of service, those bits only, right? And in MPLS, whenever you will configure quality of service, you will configure experimental bits. Hey, you will use experimental bits in MPLS. So now let's say that we have configured some quality of service in MPLS itself. So we will be using experimental bits. We have provided some extra treatment for that traffic which is going for 4.4.4, which is going towards 4.4.4.4. So we have modified their experimental bits. Now the problem is that when R3 is giving packets towards R4, it is removing your tag. So those experimental bits will not be received by R4. So how will it be possible for R4 to understand that okay, this traffic is more prioritized over other type of traffic? Are you getting my point or not? If your label has been popped before one hop, then last hop like R4 will receive it on S1 by 0 and it will treat that traffic as a normal traffic. However, we have already provided some special treatment for those packets which are forwarded in the direction of 4.4.4. Piyush, are you getting my point or not? So because that label has been removed by R3 itself before transmitting packet towards R4, so R4 will never come to know that okay, these packets are having some special treatment. Are you getting my point or not? Have you understood it? And it is happening due to penalty mate hop popping. To solve this problem, now on to R4, do one thing. I mean, if you are having that kind of situation, in that case you can say MPLS LDP explicit null. In place of implicit null, you can start to use explicit null for all prefixes which are directly connected to this device now. So R4 was having this 4444 as directly connected. Now previously it was advertising implicit null towards its neighbor, which was label number 3, but this time it will start to advertise what? Explicit null. And the meaning by explicit null is what? Label number 0. Label number 0 will be denoting your explicit null. So this time it will generate explicit null. So for R3 its outgoing label will be what? Explicit null. You can check its forwarding table now. Show MPLS forwarding table to reach 444. Now its outgoing label is what? 0. Outgoing label is what? 0. It's not pop tag. It is not pop tag. It is now 0. And what does it mean? That whenever it will receive any packet coming with label number 18, it will swap it with the 0. It means experimental bits will get copied into this new label now, right? Hello? So that whenever R4 will receive this packet, it will receive this label and label number will be 0. So it will also receive experimental bits. It means now it can assume or it can understand that okay, all these packets which are having these experimental bits are having higher priority or special treatment. Are you getting my point or not? So this time those experimental bits will be delivered onto R4 as well, so that R4 can easily come to know that okay, these packets are having some special treatment. So this time this popping will not be done by R3. Now you can ask me, sir, now there would be a recursive lookup on R4. No, there will not be any recursive lookup. You know why? Because this time R4 will receive it with the label number 0, and if any packet is coming with label number 0, then it will open its IP header as well, and then it will perform lookup directly in its fib, not in its LFIB. Because if any packet is coming with the label number 0, it means, are you getting my point? that it does not have that entry in its local LFIB, so it will not perform lookup in its LFIB. So there will not be any recursive lookup, and also you have you have advertised your experimental bits up to R4. Hello, have you understood the uses of explicit null here in LDP? By default, for directly connected prefixes, it always advertise what? Implicit null, which is label number 3. But for that label, it will always perform popping. Neighbor devices will always perform popping. That is why R3 was performing popping previously, but now it is not performing popping. You can see that outgoing label is what? 0. Have you understood it? For sure. Shadi.
The R3 will configure outgoing label as 0
Yes.
and it will send to R4.
Yes.
So R4 is not going to LFIB.
Exactly. Because if it is looking up its LFIB first, then there will be recursive lookup, because it will not get anything in its LFIB 44444. Because 444 is directly connected to R4, right? But there is a rule in MPLS that if you receive any packet with the label number 0, it means you will never get that entry in your LFIB. So it will not perform lookup in its LFIB. It will perform lookup directly in FIB. But what is the advantage of adding this label number 0 now? Now R4 can get those experimental bits, right? So that it can classify your data. Are you getting my point or not? Hey, it will get your packets with those experimental bits in which you have defined that these packets are having that much priority.
But also recursive lookup is going on.
Why?
It's not going into LFIB and it's going to FIB.
Simple. So it will perform lookup in FIB only. So what is it? Recursive lookup. Recursive lookup means when it is performing lookup in LFIB first and then it is moving into FIB. Recursive means you are performing routing lookup 2 times. That means recursive lookup. Otherwise, if routers are defining, performing lookup only once and we are calling it recursive lookup, it means all devices are performing recursive lookup now. Recursive means when it is performing dual lookup. So there is a rule in MPLS that if you receive any packet with the label number 0, you will never perform lookup in your LFIB. You will directly perform lookup in your FIB. Fine. Then you can move back again on R4, and in place of explicit null you can say MPLS LDP. Okay, one more thing. Along with the explicit null, you can also say 4 and 2. 4 means you can define your LDP prefixes. In it, you will call your ACL. Are you getting my point? Hello? Only standard ACL is allowed. So in this ACL, you will call only those prefixes. You will permit it only those prefixes for which you want to advertise your label as explicit null. And then let's say it is 1, then 2. For which pair you want to advertise it. So this is more, it would become now more granular, right? So you can configure your device to advertise your label as explicit null for a specific prefix towards a specific neighbor as well. Now once again move on R3 and you will see that its outgoing label will become now what? Fine. And on R2 you can also say, or on R3 also. Okay, you can do it on R2 as well, like debug MPLS packet. From R1 you can try to ping with, move on R2 now. You see, it received one packet on S1 by 0 with label number 19. It transmit it out from S1 by 1 with label number 18, because 19 was swapped with 18. And then packet came back from there, ICMP echo reply. It came with label number 19 and it replaced it with label number, no, it's showing you only those packets which are going towards there. It is not showing you all those packets which are coming from there, because for that I think show MPLS forwarding table. Let me show you. To reach 12.1.1 is directly connected to R2. That is why it is not switching those packets based on alpha. See, R2 is not switching those packets which are coming back from R4 towards R1 based on alpha. You know why? Because in source we were having 12.1.1.1 and 12's network is also directly connected to R2. And that is why R2 do not have that entry in its LFIB. And now R3 is performing popping for 12's network. You see, R3 is performing popping for 12's network. That is why R2 didn't get R2 didn't get packets coming from R4 with any label, because popping has been already done by R3, because 12's network is also directly connected to R2. But what can we do from R1? We can say source is what? It's on loopback. Now you will see that R2, see, this time it will show you everything fine. Like it received one packet on S1 by 0 with label number 19. It have transmitted, see, XMIT means transmit, out from S1 by 1 with label number 18. Then it received ICMP echo reply onto S1 by 1. And of course it will receive it on S1 by 1. If it receives anything with label number 16, then it will transmit it out from S1 by 0 without any label, because R2 is performing what? Show MPLS forwarding table. It is performing popping for 1111. That is why now whenever, see, it will receive any packet with label number 16, it will send it out from S1 by 0 without any label. That is why it received packet on S1 by 1 with the label number 16. It have transmitted it out from S1 by 0 without any label. Tell me. Hello. Have you understood it or not? So basically what I explained to you in previous class, everything has proved over here. We have proved everything. PSP and all these things, right?
सर एक इसमें दो होल्ड डाउन टाइमर्स होते हैं मेरे का, एक 15 सेकंड्स का और एक 180 सेकंड्स का.
For LDP hello messages it is, you know,
15 seconds का.
yes, for hello messages, but for TCP keep alive it is 180. Sometimes let's say you are keep on to receive hello messages from your neighbor. You are keep on to receive hello messages from your neighbor, but you have stopped to receive keep alive messages, TCP keep alive. So it will break its TCP session after 180 seconds. But if it have stopped to receive hello messages, then it will break it after 15 seconds only. Let me show you. First of all, I will filter your hello messages only, right? So to filter hello messages, what will I say? Access list 101, deny UDP, any EQ is what? 646. Then access list 101 permit IP any, and then go to S1 by 0 IP access group. You understand? 101 in which direction? In show IP access list. Check it out. So see, one packet has matched, 1, 2, and now you see 3. Neighborship has gone down. Understood? Now Show MPLS LDP neighbor. Show okay, I'm on R2. I configured everything on R2. Oh my god, no problem. Show TCP brief. See, does it have anything over here? Move on R2 once again. Go to serial 1/0 and remove this command so that it will start to allow hello messages now, and you will see that neighborship will come up once again. It have came up now, right? Move back again on R1, and this time I will filter TCP messages. So this time it will take 180 seconds. Access list 110 deny TCP any EQ what? Then 110 permit IP any, then interface as 1/0 IP access group, show IP access list. You have to do wait for that because keep alive interval is what? 60 seconds. Neighborship went down, and after removing it, it have came up once again. So in this way, these hold down timers works. Fine. In LDP, you can also configure authentication, and by default, it will support MD5 only. It will support only MD5. To configure that, now as you know that we are having authentication. I have to configure neighbor authentication for 22222, right? We are having TCP session with 2222. So I'll say MPLS LDP neighbor. (222) password. It's done. MPLS LDP neighbor 222. However, LDP neighbor is in hello messages. We can see that our neighbor is what? 12.1.1.2. But you see, I configured it for TCP neighbor because everything is running over the TCP session only, right? So you see that now we have to move on R2, and on R2 also I have to say like MPLS LDP neighbor 1.1.1 password is Cisco at 123, and by default it is using MD5, same as BGP. So this authentication information is contained by TCP itself, right? Same as BGP. Inside TCP header, inside option field. Understood? So once again you can see neighborship have came. Then after, if you want to form your neighbor LDP neighborship statically, it is also possible. You can also configure targeted neighbor. You can also configure targeted neighbor. To say static neighbor in LDP. That's possible. But remember, then after it will start to send unicast hellos. So for doing that, you can say now like MPLS LDP neighbor is 2.2.2, and then you can say targeted. Previously it was you understand, like I hope that you people are getting this point, right? So it will not send multicast hello, it will send only unicast hello. And then on to R2 also you can say MPLS LDP neighbor and then targeted. Clear MPLS LDP neighbor star. Show MPLS LDP neighbor. Fine, it have came up, and you see Unicast hellos. It's not it. Open it. I hope you people have understood it. Tell me. So in this way you can see that they are sending now hello messages. Even if you want to configure indirect neighborship in between R1 and R4 LDP pairing, then you can also do that. And I have already told you that in which conditions you will require to configure targeted LDP sessions. Like I told you in FRR fast reroute, if you are going to configure FRR in MPLS, if you are going to configure NSF non-stop forwarding, it's not it. So in that requirement, I mean in those types of requirements, you can configure targeted sessions, targeted neighbors in MPLS. I hope that you people have understood it, right? So in this way you can configure static neighbor in LDP. In this way you can configure authentication in LDP. Apart from it, right now you can see that R1 is receiving okay. Now one more thing, in MPLS it is not good to configure summarization. Try to configure summarization only on source router if you have configured MPLS. Otherwise your LSP labeled switch path will be broken into two paths if you have configured summarization anywhere in the network. Like I'll prove it over here. Like on R4, I'll do one thing, create loopback 41, like 40.1.1.1. Fine. On R1, show IP route, see all these prefixes. All these 40s prefixes, right, are there. And for all 40s prefixes, show MPLS forwarding table, check it out. Its outgoing label is what? I mean it is receiving label from R2 for each prefix separately, is not it? Are you okay with it or not? So whenever it will receive any packet coming with 16, it will swap it with 20 without any problem. And in it will be better for us to have one another router actually after R1 as well. So let me have that actually. Let me connect it to R1 and I'll say F1 by 0 with F1 by 0, right? So here I'll be using network of 15. Sardeep, नींद आ रही है? 15.1.0/24. So at the end of R1 on F0 by 0, I'll say 15.1.1. At the end of R5, I think we were using ACRP AS1 itself, right? Fine. Show IP. Okay, one more thing. Interface FA0 by 0 MPLS IP and then on to R1 as well. Fine guys, there should not be any problem. Good. Now R5 must receive all those prefixes. Show MPLS forwarding table. Check it out. Is not it? Now what I did, I have decided to configure summarization on R2's S1 by 0. I get your point. On to R2's S1 by 0. IP. Is this R5 visible to you? Router 5. On to interface S1 by IP summary address EICRP1 and then 40.1.0.248.0. R2's S1 by 0. Fine. Check it's on routing table. Null 0 entry will be there, which is, like directly connected, right? Kind of directly connected. Now see, show MPLS forwarding table on R2. It is having all these prefixes. Outgoing label is there. No problem. But now R2 will advertise only and only summary address towards R1. Hello? And R2 will generate local label for that summary address as implicit now. So whenever R1 will receive it, show MPLS forwarding table. For that summary address, its outgoing label will be pop tag. But its local label is what? 26. So whenever it will advertise it towards R5, its outgoing label will be what? 26. Check it out. To reach 40 is prefix. Fine. Now let me explain to you. Whenever from R1, I will try to send data towards 40.1.1. Are you getting my point or not? So it will send it with the label number 26. Fine. Whenever R1 will receive it, it will receive it with the label number 26. So it will perform pop. Pop means now it will send unlabeled packet. So whenever R2 will receive it, it will receive unlabeled packet. So it has to perform in lookup in its FIB. Hello, I have already taught you this rule so many times that if a router receives a labeled packet, it will perform lookup in LFIB. If it receives unlabeled packet, then it will always perform lookup in its FIB. So now see, on R2 it will perform lookup in its FIB, not in its LFIB. So your LSP has been broken or not? LSP label switched path. And in case if you do not use this summary address onto R2 now on S1 by 0, just remove this summary address from here. You will see that now LSP will not be broken. Will not break over here. You know how? Like R2 is not giving now summary address to R1, right? It will be advertising all those prefixes individually. So you can see to reach 40.1.1.1, its outgoing label is now what? 20 and local is 16. So it will advertise it now towards R5. And for R5, of course, like to reach, MPLS forwarding table, you see to reach 40.1.1 outgoing label is what? 16. So it will send packet with the label number 16. So R1 will receive it with the label number 16. And then if it receives anything with the label number 16, then it will switch it out from S1 by 0 with the label number 20. So now R2 will receive it with the label number 20. And if it receives anything with the label number 20, then what will happen? See, it will again swap it with the label number 20 itself and will send it out from S1 by 1. So see, this time LSP will not break. LSP label switched path. Is there any router now who will perform lookup in its FIB throughout the path? Hello, have you understood it or not? That is why it is not desired or it is never recommended to configure summarization on any router if you have configured MPLS. Try to avoid summarization in MPLS domain. Otherwise, your routers, your traffic might get dropped. I'll show you. Even I will show you that okay, traffic is dropping now during MPLS VPN, because at that moment on core devices I will not be having your prefixes. And then I will show you that, see, I have done this summarization, and due to summarization only this problem is occurring over here. So I hope that you people have understood this concept. Fine. So it is never recommended to configure summarization in your MPLS domain. Understood? Fine. Let's go for next topic related to LDP now. So after doing it, now let me show you that even you can also control your LDP to advertise labels towards your peers. Like right now R2 is advertising labels towards R1 for all prefixes, for all 40s prefixes, you understand? So in LDP this option is also available, this characteristic this character is also available in LDP, in which you can, this function is also available in LDP by which you can control your label advertisement. You can control your label advertisement. Do you remember that in BCP we configured conditional route advertisement? Conditional route advertisement, like if this is existing and all those things. However, there is no conditional advertisement, but you can configure, here in LDP also we will call it conditional label advertisement, but here you can simply control them, that okay, for which prefix you want to advertise label towards your neighbor and for which prefix you do not want to advertise your label, right? So right now R2 is advertising label towards R1 for all prefixes, right? What I want that it should advertise, see, R2 should advertise labels towards R1 only for first 3 prefixes in the range of 40s network, not for any other prefix. So now what will I do? First of all, I'll say MPLS LDP label advertise labels. So say no, just remove it. This command is pre-configured over here. This command is pre-configured in MPLS. So I have deconfigured this command, no MPLS LDP advertise label, and after doing this after configuring this command over here, you will see that on 2R1 there will not be any label. It will not receive any single label for any prefix now. See, it have stopped. R2 have stopped to advertise any label for any prefix now. But now with using some ACLs, you can force it to advertise some labels towards its all prefix or all peers for some specific prefixes only, right? So to achieve that task over here, what can we do? I'll say, first of all, I have to create ACL for those prefixes for which I want to advertise labels. So I'll say access list, or I'll create name ACL, IP access list, IP access list standard, and advertise prefix. It's too big. I'll create it in this manner only, like access list 1 permit, and then I'll say like 40.1.0.0, then 0.3.245. So only first 3 prefixes will be allowed and all others will be implicitly denied. Then access list 2 permit any, because I want to apply it for all peers. This ACL number 2 is for neighbors. ACL number 1 will specify your prefixes. Are you getting my point or not? Hello. I created 2 different ACLs. ACL number 1. These are not sequence numbers of common ACL, right? I have created 2 different ACLs over here. ACL number 1, which I'm using to represent your prefixes, and ACL number 2, I'm using it to represent your peers, LDP neighbors. Fine. Then do one thing, say MPLS LDP advertise labels. Now there are 2 keywords, 4 or 2. So 4 means your destination prefixes, your prefixes, which is ACL number 1. Then 2 means your peers, which is ACL number 2. So it will start to advertise labels for only for those prefixes which have been permitted in your ACL number 1 towards all those peers which are permitted in ACL number 2. So this time if you move back again on R1, you can move back again on R1 and you see that for first 3 prefixes of 40s range you will start to receive labels from your neighbor, and for all other prefixes it is still untagged. See, it is not receiving any label for any other prefix from its neighbor. Hello, this is called conditional label advertisement. Conditional label advertisement. So I hope that you people have understood it now. So is there any problem in it? Hello, in the configuration of LDP now? Tell me. So over there in the shoot, what can they do? They will ask that you need to ping with this prefix. You should be able to ping from here to there. In somewhere, I mean, in between those two sites, there will be MPLS domain, there will be service provider, and it will be running MPLS over there. And only for that prefix only to whom they ask you to ping, they can do this. They can filter label. So it will not advertise a label. And if it is not advertising label for that prefix, it means that data will not get switched based on label for that prefix, for that specific prefix. It means your data will start to get dropped, because now for that prefix it will start to perform lookup in its fib, and in fib that prefix will not be available. So definitely your data will get dropped. So I'm just giving you the demonstration of VRF, virtual router and forwarding. So you have to start it now. Virtual router and forwarding. Have you heard about VMware before? So what do you mean by VMware? Like virtual machine, right? Like on a single physical machine you can install multiple virtual machines. Are you getting my point? On a single physical machine you can install virtual machines, right? In same manner, on a single physical router, if you want to create multiple routers, on a single router, if you want to create multiple routers, that will be known as VRF. One VRF means one virtual router. So if you want to break your one physical router into multiple routers, like 1, 2, 3, 4, you can create multiple VRFs.
We can configure switch as VM switch.
As VM switch, don't say VM
Like-
switch over
like
here. VRF. Say, ask me that is it possible to create VRF onto switches? Yes, it depends on platform. Some platform supports VRF, some platforms do not support VRF. So you have to go through that actually. But in case of routers, most of the routers support VRFs. And it is really mandatory in terms of service provider to configure VRFs. Because sometimes what happens, let's say that we are having, like this is ISP or service provider, right? This is service provider. This is company, let's say Network Bulls and BT. This is Accenture. This is Edison. All of them are connected with this service provider, and they are also having their other branch offices as well, and BT somewhere else. Accenture, you understand? Edison. And if they are using same prefixes at their own end, like they can use same private addresses, right? And BT cannot ask to Accenture to do not use those addresses, because everyone is free to use any private IP address. And this is not internet, right? They are having simple end-to-end connectivity, right? So now how will it be possible for service provider to separate their traffic now? Are you getting my point? So basically now there will be use of VRF. Like on a single router we can create multiple VRF, and we can create a dedicated VRF for a customer. And now in multiple VRF you can have same prefixes, there will not be any problem, because one VRF is equal to one separate router. And with using that, you can separate their traffic. I mean their traffic, I mean their routes, their prefixes, their traffic will never mismatched after creating VRF. I'll be doing that, don't worry about that. Right now you will be puzzled actually that okay, how will it be possible? So I will do that. I'll explain you each and everything related to that. But for now, just try to understand this VRF in that manner that we can break our router into multiple routers. Like if you are using only and only global routing table on at the end of service provider router, then prefixes are same prefixes are coming from NBT, Accenture and Ericsson. If it is receiving same prefix, then it has to define its best path. Might be its best path is via NBT. So Accenture site 2 has sent some traffic towards site 1 and service provider will send that traffic towards NBT because its best path to reach all those prefixes is towards NBT. It's not it. So of course their traffic will never go from one side to another side. If we are using only and only global routing table. Global routing table is like till now we were working on. Till now we were working only on global routing table, right? Like show IP route. What does it show you? Global routing. Right? So basically to solve this problem now we are having here concept of VRF. Virtual router and forwarding. VRF is what? Virtual router and forwarding. Right? So if you are implementing VRF without MPLS, it is known as VRF Lite. If you are implementing VRF without MPLS, then it is known as VRF Lite. So if someone asks you that, okay, what is VRF Lite, then you would simply tell them that, okay, we are implementing VRF, but we are not implementing over there MPLS. So if you are using VRF without MPLS, it will be known as VRF Lite. If you are implementing VRF with MPLS, then of course there will be some types of like VPN and all these things. I mean, then you will call it simple VRF. You will call it VPN. I mean, VRF will be equal to VPN. However, technically one VRF is kind of like one VPN. Fine, guys. Now remember, one interface of router can be member of either global routing table or VRF. You cannot make one interface member of multiple VRFs. At one time it will be member of only one VRF. Yes, if you are having sub interfaces, then you can put them into multiple VRFs, because you can also create sub interfaces if you are remembered. Fine, so don't worry about that. I'll teach you all these things in next class now. I mean this VRF and all.
Both sides you have to get.
What?